알고리즘 세션 매우 반갑습니다. 오랜만입니다. Today I have prepared a short presentation, Introduction to Human Interaction Recognition. My name is Sangkok Cha and very welcome to my talk. Today I prepared three contents. One is Introduction to Human Interaction Recognition. Next, benchmarks. Last, general approaches. It is the summary section. Introduction to Human Interaction Recognition. Fundamental visual recognition techniques are insufficient for human interaction recognition. Giving you an example, let's say we want to recognize if a man is calling, talking on the phone. I prepared two figures. Left one, man talking on the phone. The right one, man holding the phone. First, we may detect human and phone. Next, we need to determine if the man is calling. Technically, we can handle it naively. I prepared some simple algorithm that determine if man is calling. Given human and phone, we need to find display side and check. However, actually it is impractical and expensive engineering. Solution to the demand, human interaction recognition arises. If you have any questions so far? Cool. So in this presentation, I present some benchmarks. Those are similar but a bit different tasks. And each benchmark's state-of-the-art approach in the benchmark section. And last, summarizing the general approaches, I will give you a high-level explanation for general approaches in general approaches section. Through this presentation, I want you to think what is human interaction recognition and how others have solved the problem. If you can take the two ideas, then it will be enough participation of the presentation. Benchmarks. Benchmarks represent research field's objective. In this section, I introduce benchmarks along with their state-of-the-art method.
각 벤치마크마다
I prepared three
코스가
major
있다는
benchmarks: HICO detection, and WICOCO. These three benchmarks are about human interaction understanding with common objects. There are some benchmarks with non-common objects, but that is not popular and not as practical, or that is not our proposal. So in this presentation, I will deal with these three major benchmarks. First, HICO, human interacting with common objects. It is published in ICCB 2015. It has three highlight key features. It has diverse interactions compared to the previous approach, previous data set, which has 8, 10 to 40 actions. It has 600 actions included. Also, it is one another important thing that it is sense-based human-object interaction categories. It has sense here means not word-based. Giving you an example, for us, repair a bike and fix a bicycle all the same in our sense, of course. However, the previous data set like QHY or 89 action data set, those deal with those categories as distinct points. However, since HICO, it regards those ideas, those categories the same. Last, they are multi-label. I will give you some example. let's say we have bicycle. We the left first one. We have bicycle on the man. Then we will have many correct labels. For example, man hold bicycle, yes. Man ride bicycle, yes. Man sit on bicycle, yes. Man walk bicycle, no. Man straddle bicycle, not so sure. Man wash bicycle, no. As you can see, it is ternary label, yes, no, and not sure. Any questions so far? Cool. So, task description. The task is multi-label classification. Categories are hold bicycle, ride bicycle, repo cell phone, and etc. So our task is to classify the multi-labels. Given an image, we need to find correct category. It has 80 objects from MS Coco setting. MS Coco setting is very popular basic default setting in computer vision recognition field. So it has 80 objects: bicycles, cell phones, banana, zebra, umbrella, and so on. It contains 80 objects, and in total it has 520 HY categories. Like hold bicycle, it becomes one HY category, and ride bicycle, it becomes D1, and blah 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 blah. So it has 520 HY categories in total. If you have any question or any comment on Pico data set. So now I'll move on to the next one. Like now I am going to introduce you state-of-the-art operation Pico dataset that is called detection free, DEFR. It is published last year in our archive. There are some models, but as you can see here, it shows very overwhelming performance than the others. This one is the framework overview of DEFR. Given an image, it encode the image. So we may have encode the image feature, and we have text, and through text encoding, like via BERT and kind of NLP models, we will have text embeddings. Given text embeddings and image embedded, we do something and we classify multi-level classification. Actually, it is actually the same as CLIP. So you can see DEFR as CLIP plus their own training method, their own laws. For those who do not know CLIP, I will give you a simple explanation. The left figure is the CLIP overview. It it has two encoders. Like one is image encoder and the other one is text encoder. In image encoder, image encodes into image feature, and there are many texts, and text encoder encodes them. So we got many text embedded here, and by combining them, we will have confidence scores here, like I1 times T1, I1 times T2. We will have confidence scores, and CLIP classified corresponding sentence by this confidence score. Is there anyone who needs more explanation on DEFR? Or any question? Good. In summary, for your information, in contrast to previous approaches, DEFR brought multimodal, NLP knowledge concept and got overwhelming performance. Like 학계, 배워서 by adopting, NLP knowledge, you could have very astonishing performance. Next, I've brought Kiko detection benchmark. Human interacting with common object detection, published in WACB 2018. These are the examples. The different thing from the previous one is the boxes. You can see some bounding boxes, like blue boxes are human detected box, and the green boxes are object detected box. So we detect human and object, and we match, and we classify the match, the matched ones, and classify the interaction. As we can see in the bottom, there can be multiple person or multiple object as well. Task requires detection, humans and objects, matching human and object, and classifying the interaction. It is the task. This figure explains general approaches. Like, let's say we have the top image, riding bicycle. We will conduct detection, human and object respectively, and we match them like corresponding pairs, and last we will have classification, interaction classification. These kind of methods are called two-stage approach. In two-stage approach, we first detect, and second, and next we match and classify the interaction. These approaches are called two-stage approaches, and there are some other approaches called one-stage approach. It detects and classifies the interaction at once. Like in the figure, let's say they do detection and interaction classification at once, like by transformer. Like it is very similar to detecting transformer. If you have any question, feel free. So the contributions of the data set, it is the first large benchmark for HY detection by augmenting equal classification with instance annotations. It provides tens of thousands of images and hundreds of instances and bounding boxes. Now, state-of-the-art approach on key code detection called QAHY, published in last year, archive. This is the lead mode of key code detection. The first one, AHY, is one-stage approach, transformer-based, and the next one is two-stage approach, and the third one is clip-based two-stage approach, which what we just talked about. This figure is the framework overview of QAHY. I will give you detailed explanation. These red bounded modules are detection transformer. You can just see it as DETI, detection transformer. One notable is no language feature in appearance features, like in visual features used only. And we got anchors and HY impedance, and anchors can be thought as bounding boxes proposals, and HY embeddings are the outputs from transformer decoder. We have detection module here, and using the prediction results of them, we do HY prediction. It can be complex, but it is very simple. Like we found box, object class, action class. There are some anchors, and they do something. It is not complicated. If you're interested in it, you want to know more. I want to read the paper, but what I want to say is, it is simple. Then what we feel now. Anyway. It has, in summary, it has detection transformer and it has HY predictor. It is the QAHY overview. Any question or any comments so far? Good. Cocoa, verbs in cocoa, the last data set. It is presented in 2015. These are the examples, very similar to what we saw. Yeah, it is very similar to HICO detection, but less number of images, annotation, and action categories. it can be seen as inferior to HICO detection, but it is still one major benchmark property. It is the leaderboard of the dataset, and today we will shortly review the OCN, the state-of-the-art approach. OCN, Object Guided Cross-Model Calibration Network. This one is the overview. The main idea is to guide action by object. In other words, object prediction, effects, action prediction. As you can see in the red circle, we will predict object class, and object class effects action prediction. It has three modules. One is object detection module, next one is vocabulary module and HR predictor. The first object detection module is just the same as detection transport. They detect person and objects. And here, vocabulary embedding is very similar to prior ones. Like we will have word embedding here, like from bird, or the kind of NLP models, and they do very simple something, linear something, and they got something, and combining with doing something with object class prediction result, they do something, and they result in action related. So we got object detection related something and action something, and using those two in the HR predictor, they predict human object interaction. Something. It can be seen complicated now, but it is not much complicated than if you want to know more, just visit the original paper. So, some summary, their main idea is to guide interaction prediction with object prediction. And the module consists of detection module, action embedding module, and HR predictor. So far so good? Cool. So this one is the last section of today. In here, I will provide you high-level explanations for HIR approaches. There are two HR tasks dealing with common objects. One is HI classification, the other one is HI detection. First, HI classification. We provided clip-based approach. Contrast to the previous approaches which neglect NLP knowledge or multimodal things, it showed overwhelming performance. So I am introducing the clip-based approach only. So the HI classification approach was like this. When we given an image, they got picture, and using some sentences, they encode using words or the NLP model, and they got text feedback in blue box shapes. And just combine them, we got scores, and determined by the external data scores. As you can see here, the actual model size can be as minimized as vision encoder. AII, our team is researching and developing HR. Contrast to the previous one, it just got detector instead of vision encoder, and it has HI head additional. This one is the overview for HI detection approaches. I think for those who research in vision, you may understand fully or enoughly, I hope, hopefully. And for those who are not familiar with vision field, but I still want you to get what I want to say. So, conclusion. Today, I have introduced human interaction recognition, visited some benchmarks along with their state-of-the-art approaches, and I gave you high-level general approaches, high-level explanation. Thanks for your attention. And this is the end of our presentation. 만약에 HI, 그러니까 휴먼 인터랙션 리코그니션이 뭔지에 대해 한번 생각을 해보셨고, 다른 사람들 이거를 어떻게 생각을 해봤나, 어떻게 풀었나에 대해 한 번씩 생각을 해보셨다면 아마 제가 오늘 전달하고자 하는 내용을 충분히 이해하셨을 거라고 생각합니다. 질문이 있으셨거나 뭐 코멘트 있으시면 매우 환영입니다. 발표 들어주셔서 감사합니다.
Question.
Yeah.
Is human interaction recognition synonymous with human object interaction recognition? Or does one include the other?
Actually, it should be human object interaction. It should be. I think your correction is right. Very good. Thank you for your comment.
One more?
Yeah.
Eh?